Hey there guys, it's Tim Golf 5 Tango Mike from the south coast of England. Thanks for tuning in again. Now, what I've been doing in the past week or so is trying out a very simple and what's turned out to be a very effective vertical antenna for DX. The antenna itself is simple. It's a one wire, one 49:1 transformer and some coax into the rig. Sounds simple, doesn't it? Well, let's take a look at what it looks like in the garden and we'll take a look at how well it worked. So there's the 49:1 transformer. The green wire going up is the antenna wire going up the fiberglass pole. About 10 metres up, 33 feet. And back down it comes, there we are. And there's the coax, it's EcoFlex 10, about the equivalent of LMR 400 in the States. Very low loss coax. I've only got about a 7 metre run, about 23 feet run into the shack and up to the rig. So all very, very simple and hopefully quite low loss really. And that goes in, of course, to the bottom of the transformer. And there's the coax running into the shack. All very, very simple. So the antenna itself then, as you see, is 33 feet. That's about 10 metres long vertical wire straight up. Now, the good thing about the end-fed half wave is that it's got obviously a half wave at its fundamental frequency, as we'll see at the moment. So that's 20 metres. But when fed with a 49:1 transformer, you also get the next harmonic and the ones after that. But in this case, we're just going to get 10 metres. So we've got 14 and 28 megahertz. Now, as we can see, looking at the pattern, the current pattern, if you like, for 20 meters, we'll see it's just like a dipole, really. The main lobe, if you like, is in the middle. The current maximum is in the middle of the wire itself. So it's voltage fed. So the ends, just like dipoles, are quite high voltage. So you'll be very careful in terms of where you feed the antenna. Mine is low, so I made the family fully aware not to go touching that particular part of the antenna when I key up and speak. But as you can see, basically it's just like a dipole with a current maximum in the middle. Now, looking at the 10 meter part of this antenna, same piece of wire. As you can see this time, the 10 meter version, or the 10 meter frequency, now has two main lobes. Because it's broken up a little bit because it's a full wave antenna on 10 meters. So you've got a current maximum at about halfway up the first half, so it'll be about 8 feet off the ground, about 2.5 meters or so. Then, unlike the 20 meter pattern where you have the current maximum in the middle of the wire, we then have a little null, and then we have another current maximum about 3/4 of the way up the wire, which is about 7.5 meters, around about sort of 25 feet or so. So there we are. So we have contrasting patterns of current coming from these two frequencies. So using MMANA, the modeling software, I've been able to look at not just the current patterns as you've seen there, but also we're going to look now at the SWR. So looking at this table, we can see that the SWR reading for the predicted SWR for 10 meters at the top there was about 1.4 to 1 at its center frequency of 28,450. And at 14,150 for 20 meters, we're looking at about 1.3 to 1. Now, looking at the actual readings themselves from by the way, those SWR readings or predictions on MMANA is at the feed point. It doesn't take into account any losses in the feed line, if you like. So the coax I'm using, as you can see from the earlier sort of footage there, is quite thick. It's called EcoFlex 10. It's basically on the same level as LMR 400, the ones they use mainly in the States. So very low loss indeed. So the SWR readings at the rig end, as we'll see now from the Rig Expert antenna analyzer there, not too dissimilar really, as we thought. As you can see, pretty much anticipated. If we look at the 20 meter curve first of all, and then looking at the 10 meter one. So as you can see, both frequencies are very usable indeed using this one wire. So looking now again at MMANA and that same table we looked at just now for the SWR predictions, it also gives us an idea of what it thinks will be the angle where both of these frequencies will see maximum gain from this antenna. So looking at the table first of all then, we can see that at the top, shaded in yellow, we've got 10 meters. And it seems to think that the angle of maximum gain for 10 meters would be 36 degrees at around 3.7 dB. Now for 20 meters, a much lower angle of takeoff, about 20 degrees for its maximum gain of about 0.1 dB. So looking now at the far field plot then, again on MMANA for the 20 meter frequency. And as we can see, we've got about a gain of minus 5.1 at 5 degrees off the horizon, which I think contrasts with the figure of around minus 6 for a quarter wave ground mounted vertical. And at 10 degrees off the horizon, still a very good angle for DX, we're looking at minus 1.6. Now that contrasts with the 10 meter version, as we can now see, the 10 meter far field plot, where at 10 degrees we're getting a figure of about minus 5 dB. So at 20 meters we're getting about 3.5 dB greater gain at 10 degrees off the horizon compared with 10 meters. But if we continue looking at the 10 meter version, we can see we get very good gain between about 25 and 45 degrees off the horizon. Pretty good for stuff into Europe, for sporadic E. And in fact, you can see there, that's where we get the angle of highest gain at 36 degrees, which is 3.7 dB. So comparing the far field plots now of both of these frequencies. So as we can see from the diagram, it's quite clear that 20 meters has naturally a lower angle of takeoff compared with 10 meters. But 10 meters has some reasonable gain at reasonable angles of between 25 and 45 degrees. So how well did they do? Well, 20 meters. One evening I was on, I think it was Thursday last week, and the bands were pretty good. So I worked about 6 or maybe 5 or 6 of the colony, special event colony stations out in the States celebrating the 4th of July. Worked down to Barbados, all on 100 watts, by the way. And on the Sunday morning, there was the IARU worldwide contest. I was only on for about 45 minutes, not even that. I worked about 30 stations on 20 meters of search and pounce all around Europe. And I was on very early in the morning. I was on about 06:15 UTC. So that was okay. And then for 10 meters, I was really surprised that on that same Thursday evening, I heard and worked November 8, India. Again, all on SSB, by the way. This is all phone contacts. And that was 100 watts. That was Jeff over in West Virginia, N8II, 5.3 both ways. Thank you very much, on 10 meters. So I was very pleased with that. And then again, I went on 10 meters for the same contest, the IARU contest on Sunday morning, just for about half an hour, and worked about 20 stations around Europe. So, you know, overall, for what it is, it's a piece of wire connected to a 49-to-1 transformer, an end-fed half wave and a full wave on 10, end-fed half wave on 20 meters. And you know what? Had a lot of fun with it. And if you're really, really strapped for space, you can only get up maybe a 10 meter pole and one antenna, then this could be something you could be looking for. It will be slightly noisier, probably, than a centre-fed antenna like a dipole or a doublet. But in terms of simplicity, just got to attach it to the pole, put the pole up, plug it in, you're on the air. I didn't use a choke. I didn't have to use a counterpoise with this. I didn't use a ground rod, running 100 watts with a good match, which I had anyway on both frequencies. I didn't have to worry about that, to be honest. On both bands, I didn't have to worry about that, to be honest. So, all good, all very happy. And I think it's a good, very good antenna, certainly for portable operation and for someone who's really strapped for space. Then a vertical, providing it's not too noisy, can get you some really good low angles of radiation and work you some decent DX. And I was very surprised by how well it worked on 10 meters. It's opened my eyes up a bit, actually. I thought it would be a real cloud burner, wouldn't work any DX. But of course, if you listen to everyone's opinions and all the forums that you read, you'll probably never ever put up any wire or any antenna ever. Just get something up and have some fun. And I've learned a lesson there, I have to say to you. And if you want to find out more about end-fed half waves and how they work, well, click up here for a little guide. Take care and thanks for watching and stay safe. 73.